liners, welcome to the channel Transmission Lines Engineering TV. Thank you very much for your company. This is the fifth video of the series Wiring the World, in which we will talk about the electrical development of the regions of Japan, Africa and Madagascar. So let's start with the region of Japan. Japan is a small nation in territorial extension, but immense in technological advances based on the will and determination of its population. The history of the Japanese electrification begins back in 1883, when the first electric agency, Tokyo Electric Lighting, was founded. In 1887, the first large generation station was located in Minami Kayabasho in the city of Tokyo, which came into operation in that year of 1887. By 1891, there were private companies to provide electricity, companies such as Kobe Electric Lighting, Kyoto Electric Lighting, Nagoya Electric Lighting, Yokohama Kyoto Electric Lighting, Kumamoto Electric Lighting, and Hokkaido Electric Lighting, which quickly gave service to the whole country. In 1899, another hydroelectric station with 11 kV transmission line and 9 kilometers in length from Hiroshima to the community of Kyoto was installed in the city of Hiroshima. During the war between Japan and Russia between 1904 and 1905, the generation of electricity was based on steam engines until in 1907 the Komahashi power station came into service, and from this year the Japanese transmission line systems had a remarkable development for the efficiency of long-distance transmission lines based on hydroelectric technology, and the first 55 kV line with 76 kilometers was built. By 1906, Japan has an infrastructure of transmission lines of almost 4,000 kilometers of transmission lines, having large hydroelectric projects. Japan further developed its electrical industry after the First World War in the period of 1914 to 1918, when Japanese manufacturing took full advantage of the electric power potential. An interesting fact is the speed with which Japan expanded its electrical system. From 1907 to 1931, Japan increased its transmission lines infrastructure from 4,700 kilometers of transmission lines to 266,000 kilometers of extension in transmission lines, covering the entire territory of Japan, including 4,300 kilometers of underground lines. On the other hand, as in Europe, Japanese electric installations became military targets during the Second World War, especially after the attack on the Pearl Harbor Islands in Hawaii in 1941. And many infrastructures had to be rebuilt after the attack with the atomic bomb in Hiroshima and Nagasaki, so it was imperative to have electric service in these cities precisely for the attention of the victims of the atomic attack. It is not necessary to mention that the need is the mother of the invention, so that at present Japan has one of the most extensive and high technology electrical systems and supplier of diverse materials and equipment for this industry, not only for transmission lines but for many other industries. This was a very fast overview about the development of Japan. Now we will talk about the electrical development of Africa and Madagascar. The African continent, since its inception, historically has been a long-lost zone in energy, highlighting the consequences of not having a solid electric infrastructure for the people and by the people in the 21st century. Despite this, Africa is a continent rich in natural resources that can be translated into an impressive electric potential. This is, in my opinion, a region which requires international support to implement systems of generation and transmission to boost the quality of life of the African people. The history of electrification in Africa dates back to the end of the 19th century, where it initiated the electrical system in the semi-desertic zone of the Sahara. In 1882, the first city with public lighting in Kimberley, South Africa was electrified. By 1890, the first diesel generator in Ethiopia was installed and donated by the German government. By the year of 1900, the city of Dar es Salaam in Tanzania had a public lighting system, while in 1906 in Zambia, the first thermal plant was installed. In Ghana, for its part, the railroad system, named Gold Coast, introduces the first electric service for public use in 1914. In Sierra Leone, 1928, it was installed the very first generator in diesel. There was a person named Charles Rivers Westlake, who was an English engineer, who proposed the construction of the hydroelectric project in Owen Falls, near the city of Njinga in Uganda, and came into service in 1954, which continues in service under the name of Nula Valley Hydroelectric Power Station. Another interesting project was the hydroelectric station of Cahora Bassa Dam in Mozambique, which was built by the colonial government of Portugal in 1969 and ended in 1974, but unfortunately, due to the civil war in this region, which ended in 1992, the electrical system was a victim of several sabotages for 16 years. On the other hand, the Democratic Republic of Congo from 1972 to 1982 built two hydroelectric plants in Inga Falls in the Congo River to supply the mining industry, but they were not really profitable because the mining areas were near Kinshasa, Western Congo, at 1,600 kilometers away. On the other hand, one of the great advantages of Africa, in addition of its hydraulic resources, is the high solar radiation in practically the entire continent. This is sufficiently competitive and profitable resources for the installation of solar parks because they will be able to generate throughout the whole year. Now, talking about the region of Madagascar, which is another area very rich in resources, especially hydraulics, with a lot of hydroelectric potential. Unfortunately, only 2% of this potential is taken advantage, and this few electrical infrastructure is not really in very good operation conditions. So currently, the main source of electrical energy in Madagascar is biomass and has not managed to exploit its petroleum resources. It is a region in which only 5% of the population has access to electricity service due to its very limited system transmission lines. The main transmission line of the country runs from the capital city, Antananarivo, to the city of Antsirabe, which is a line of 180 kilometers, while the rest of the cities and communities depend on small external producers. Even nowadays, in the 21st century, many communities in Madagascar are still illuminated by kerosene, firewood, or candles. At present, there are different programs are being under study to support the electrification of this area. So as you can see, it's an area, it's a region which still requires a lot of electrical development. In the next video, we will talk about the electrical development of the regions of Greenland, Iceland, Alaska, and Hawaii. So don't forget to subscribe to this channel and leave me your comments on this one. Transmission Lines Engineering TV, training to power the world.